Hello and welcome to this revision session for Paper 1 in AQA A-Level Physics. In this revision session we're going to be looking at how to answer multiple choice questions. So in this revision session we're going to be looking at how we can answer examination questions for AQA A-Level Physics Paper 1, in particular the multiple choice questions. So if we're being successful and we've learned in today's lesson, we should be able to answer A-Level Physics examination style questions, assess our understanding on A-Level Physics and understand what topics we need to improve upon for AQA A-Level Physics. So how should you prepare for this revision session? When you complete your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and in this left hand side section write down your working out and answers to the question in the revision session. When you're doing this, make sure you write your answers in full sentences and show your full working out. Whilst in the right hand side, write down any bits of information which you find useful or any hints and tips on answering questions from this revision session. After the end of the revision session, write up these notes into a revision sheet for you to use independently. So how should you be revising A-Level Physics? The first thing you should be doing is learning the key facts. Use revision guides, class workbooks, student prep notes and the textbooks to learn the key ideas of the course. You may wish to make mind maps or to write out the notes yourself. The second step is to test yourself. Use things like Caboodle, Seneca, student knowledge checkers to quickly test your own knowledge, and you may wish to do this from your own cue cards. While the third step is to practice. Practice examination style questions. Use exam prep books, homework books, supervised study books, additional workbooks to answer examination questions and mark your own work. And you may wish to download your own exam past papers to do this. So your three steps are learning the key facts, testing yourself and practicing exam style questions. So now let's have a look at some multiple choice questions in the different topics of Physics Paper 1, and we'll start off by looking at particles and radiation. So the first question says a sheet of gold leaf has a thickness of 0.125 micrometers. A gold atom has a radius of 174 picometers. Approximately how many layers of atoms are there in the sheet? So pause the video now, then unpause the video when you want to go through your answer. Now the answer is C, because the number of layers is the thickness divided by the diameter of the atom. That's a common sense equation. Now note you're given the radius, so you're going to have to double the value to get the diameter. Then it's a case of knowing micro means 10 to the minus 6 and pico times 10 to the minus 12, so you get out about 359, so it approximately equals 400. The answer is C. The next question says radon 211, francium 210 and radium 212 are three nuclides. How many neutrons does each nuclide have in its nucleus? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is B, because the number of neutrons is the larger number minus the smaller number, because the large number is protons and neutrons, the smaller number is the number of protons. So you can work out radon has 125, francium 123 and radium 124. The answer is B. The next question says, which nucleus has a smaller value of specific charge than the nucleus 18 oxygen 8? So pause the video now, then unpause the video when you want to go through your answer. Now the answer is A, because specific charge is the charge per unit mass. Now that tells us that actually it's the ratio of the number of protons, which provide the charge, divided by the number of nucleons, protons and neutrons, which provide the mass. So we can see here it is going to be a ratio of the smaller number to a ratio of the larger number. So it's 3 over 7, 5 over 11, 6 over 13, 17 over 37. Now 3 over 7 is smaller than 8 over 18. The answer is A. The next question says, when bombarded with an alpha particle, the nuclide 2512 magnesium changes into another nucleotide with the emission of a neutron and gamma radiation. What are the correct values for the nucleon number and the proton number of the nuclide which is formed? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is C, because the alpha particle increased the proton number by 2 and increased the nucleon number by 4. So the emission of a neutron will decrease the nucleon number by 1 but doesn't change the proton number. So overall, the addition of an alpha and the emission of a neutron will increase the nucleon number by 3 and the proton number by 2. So looking at their values, we're going to get the answer of C. The next question says a calcium ion is formed by removing 2 electrons from an atom of 40 calcium-20. What is the specific charge of the calcium ion? So pause the video now, unpause the video when you want to go through your answer. Right, the answer is C, because specific charge is the charge per unit mass, or charge divided by mass. Now the charge is provided by the overall charge, which is minus 2 electrons, because you've lost 2 electrons. So it's 2 times by the charge of the electron, 1.6 times 10 to the minus 19. We divide it by the total mass, which is going to be 40, the nuclear number, times by the average mass of the nucleon, 1.67 times 10 to the minus 27. So our answer is going to be equal to C, which is going to be 4.8 times 10 to the 6. Now the next question says, which of the following nuclide has the smallest specific charge? Pause the video now, then unpause the video when you want to go through your answer. Right, in this one, our answer is D, because again, specific charge is given by the ratio of the number of protons, the charge, divided by the number of nucleons, the mass. So A is 1 over 1, B is 6 over 12, C is 6 over 14, and D is 92 over 235. So that smallest ratio is D. The next question says, what is the correct equation for beta plus decay? So pause the video now, then unpause the video when you want to go through your answer. Right, in our answer here, our answer is going to be equal to D, because we know beta decay is a proton to a neutron, and it'll produce a positron, which is a beta plus. Now, when you have an anti-lepton produced, which is what a positron is, it's an anti-electron, you will get the neutrino to be produced to conserve the lepton number. So the answer has to be D. The next question says the nucleus of 9 beryllium 4 captures a proton and emits an alpha particle. What is the product nucleus? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer is C, because capturing a proton will increase the nucleon number and the proton number by 1. Emitting an alpha particle will decrease the nucleon number by 4 and the proton number by 2. So therefore, capturing a proton and emitting an alpha particle will decrease the nucleon number by 3 and the proton number by 1. So we get our answer of C. The next question says 232 thorium-90 is an unstable nuclide in a radioactive decay series. It decays by emitting an alpha particle. The next two nuclides in this series emit beta minus particles. What nuclide is formed after these 3 decays have taken place? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer here is D, because emitting an alpha particle decreases the nuclear number by 4 and the proton number by 2. So the beta decay will only therefore increase the proton number by 1. So therefore the nuclear number will decrease by 4 and the proton number will stay constant, because you can see that it'll emit 2 beta minus particles. So ultimately it'll cancel out. So our answer is going to be D. The next question says, which sequence of radioactive emissions results in the formation of an isotope of the original element? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is B, because an alpha decay will lose 2 protons. A beta decay will gain 1 proton. Then for it to have the original element, you need to have the same number of protons as you started with, so therefore 1 alpha decay and 2 beta decays will cancel through, keep the same number of protons. The answer is B. The next question says, which of the following are the base units for the Planck constant? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer is B, because we know E equals hf, where h is the Planck constant, so therefore h is E over F. Now we know energy is force times by distance, so therefore we know force is mass times acceleration, so h equals mass times by acceleration times by distance, all divided by frequency. We put in all the units in kilograms, meters and seconds. Now remember, frequency is seconds to the minus 1. Pop them all through, cancel it through, and we get kilograms, meters squared, seconds to the minus 1. The next question says, which statement concerning the forces between particles is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer is B, because leptons as a fact will only experience the weak interaction. Hadrons will experience both the strong and the weak interaction, so the only correct answer is B. The next question says, which line does not give the correct exchange particle for this process? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer for this question is A, because gravitational attraction is caused by the graviton exchange particle, not the W boson. That's a fact you've got to learn, so that gives the correct answer. The next question says, which row shows the correct interactions experienced by a hadron or a lepton? So pause the video now, then unpause the video and you want to go through your answer. Right, the answer here is going to be A, because again, the facts you've got to remember are a lepton experiences the weak interaction only, whilst a hadron experiences the strong and the weak interaction. So therefore it has to be A. The next question says, when the nucleus of a radioactive isotope 65 nickel 28 decays, a beta minus particle and an electron antineutrino are emitted. How many protons and neutrons are in the resultant daughter nucleus? So pause the video now, then unpause the video when you're going to go through your answer. So the answer here is going to be C. In a beta minus decay, a neutron turns into a proton, an electron and an antineutrino. So this will increase the proton number by 1 but decrease the neutron number by 1. So we get 29 protons and 36 neutrons. Our answer is C. So the next question says, which of the following particles is an example of a fundamental particle? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is B, because pions are mesons, they're made from quarks, protons are baryons, they're made from quarks, and a nucleus is made from protons and neutrons, so our answer is B. The next question says, which elementary particle is a lepton? So pause the video now, then unpause the video and you want to go through your answer. Right, the answer is C, because protons and neutrons are baryons, that's a fact, quarks are found in baryons and mesons, that's a fact, and electrons are leptons, that's a fact. The next question says, what of the following is a hadron of zero charge? So pause the video now, then unpause the video and you want to go through your answer. Right, our answer is D, because the protons and neutrons are made from quarks, that's a fact, so therefore are hadrons, and the neutron has no charge, so therefore it has to be D. The next question says, what are the numbers of hadrons, baryons and mesons in an atom of 7 lithium-3? So pause the video now, then unpause the video and you want to go through your answer. Right, our answer here is C, because in this isotope there are 3 protons because it's a smaller number and 4 neutrons because it's a big number minus a small number. The neutron is a baryon and also a hadron. The proton is a baryon and also a hadron, so our answer is C. The next question says, which line correctly classifies the particle shown? So pause the video now, then unpause the video and you want to go through your answer. Right, our answer is C, because the neutron is made from a down up down, that's a fact you've got to learn. The neutron is a baryon, not a meson, and a positive pion is down anti up, so it equals through, so there the positive pion, so therefore our answer has to be C. The next question says, that which of the following statements about muons is incorrect. So pause the video now, then unpause the video and you want to go through your answer. Right, the answer here is B, because muons will have a low kinetic energy, okay, much lower than the electron because it's much more massive. Okay, it'll also note that because they're moving slower to achieve the same momentum because they've got more mass. Now again, as the velocity is squared in kinetic energy, it's a greater factor in the kinetic energy, so therefore the electron is moving faster, so therefore our answer is going to be D. The next question says, how many down quarks are in a nucleus of hydrogen 3? So pause the video now and unpause the video and you want to go through your answer. So the answer here is D, because in this isotope you can see there are 2 protons and 2 neutrons and 1 proton. In 1 proton there's 1 down quark, and in 1 neutron there are 2 down quarks. So you can add them through to get our answer of 5. So that gets you your correct answer. The next question says, a neutron is composed of 1 up quark and 2 down quarks. When the neutron decays into a proton, there is beta minus emission. What is the change in the quark structure of the neutron due to beta minus emission? So pause the video now, then unpause the video and you want to go through your answer. Right, in beta minus emission, we know a neutron turns into a proton, so it means that a down quark is turning into an up quark. It'll also produce a beta minus particle, and therefore it'll have to as well produce the antineutrino to therefore balance out the lepton number. So the answer is B. The next question says, which of the following is not true? So pause the video now, then unpause the video and you want to go through your answer. Right, the answer is C. A, B and D are all correct facts to do with particle physics, but the charge of a quark can either be plus a third or 2/3. It can be either of them, so therefore our answer is C. The next question says, which of the following is not made from quarks? So pause the video now, then unpause the video when you want to go through your answer. Right, we know the answer is B, because a neutron is a baryon and is made from 3 quarks. The pion and kaon are mesons, they're made from 1 quark, 1 antiquark. We know that a muon is a lepton, which makes it fundamental, it's not made from quarks. The next question says, what is the quark structure for antiprotons? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is going to be D, because a proton has a quark structure of up, up, down. An antiproton has the same quarks, but the anti-versions, so it must be D. The next question says, electron capture can be represented by the following equation. Which row correctly identifies X and Y? So pause the video now, then unpause the video when you want to go through your answer. Right, in electron capture, we know as a fact protons turn to a neutron. So if a lepton is present, it must be an antineutrino to conserve lepton number. So therefore, what we know is it has to be therefore C, because we've got the neutron there, and we're then going to have our antineutrino, so it will be C. The next question says, what interactions are involved in the production of a strange particle and is decay into non-strange particles? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer is going to be A, because strange particles are called kaons. They're produced via the strong interaction and they decay via the weak, which is why they're observed to exist longer than they should be. So our answer is A. Let's have a look at some questions on the topic of waves. So a string of 90 centimeters is under tension T. A second string is 30 centimeters long and has the same mass per unit length. What is the tension in the second string when both strings vibrate with the same frequency for the first harmonic? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is D, because we know from our equations F equals 1 over 2L times by the square root of T over mu. So therefore T equals F squared, L squared, 4L squared mu. So therefore as F and mu are constants, if L is 3 times less for B than A, then tension must be 9 times more, because T is directly proportional to L squared. Our answer is A. The next question says the frequency of the first harmonic of a standing wave on a wire is F. The length of the wire and tension in the wire are both doubled. What is the frequency of the first harmonic as a result? Pause the video now, then unpause the video when you want to go through your answer. The answer is A, because as we know, F is equal to 1 over 2L times by the square root of T over mu. As L and T are both doubled, that then means that it'll equate that F is going to be 1 over the square root of 2 times smaller. So our answer is A. The next question says, which of the following is correct for a stationary wave? So our answer is going to be D, because the amplitude will vary between the two nodes. That's a fact for a stationary wave. You can't always be out of phase, otherwise it will completely cancel through and you get no wave. The separation of nodes is not proportional to the harmonic number, and all parts of waves between two nodes are in phase because they're all vibrating in the same direction. So the correct answer is D. The next question says, a stationary wave is set up on a stretched string as shown. Which statement about the points on the string is correct? So pause the video now, then unpause the video when you want to go through your answer. Right, firstly, Q is not a peak. S is a node, not an antinode, and we know the distance between R and S from looking at it is a quarter of a wavelength. But we do know that R and S are roughly in the same phase because they'll be vibrating in the same direction. So therefore, the answer is B. The next question says, a transverse wave with amplitude of 4 centimeters and a frequency of 10 Hz travels along a rope at a speed of 2.4 meters per second. What is the total distance travelled by a particle in the rope in a time of 20 seconds? So pause the video now, then unpause the video when you want to go through your answers. Right, the answer is E, because in 20 seconds there'll be 200 wavelengths, as is the frequency is the number of waves per second. Now in each wavelength the particle will travel 4 times by 4 centimeters, because it goes up to the amplitude and back down 4 times in a one wave cycle, so that's 0.16 meters. Now you do 0.16 meters times by 200, the number of waves, it equals 32 meters. The next question says 2 radio transmitters emit waves at a frequency of 1.4 megahertz. A stationary wave is set up between the 2 transmitters due to the superposition of the radio waves. What is the minimum distance between 2 nodes in the stationary wave? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer for this one is A, because the wavelength is speed over frequency, so it's 3 times 10 to the 8, the speed of a radio wave, over 1.4 times 10 to the 6 megahertz into hertz, so it's 214 meters. But the distance between node to node is only half a wavelength, so it's 107 meters. The next question says, which row correctly describes the wave properties that can be demonstrated by light waves and sound waves? So pause the video now, then unpause the video when you want to go through your answers. Right, our answer is B, because light waves are transverse, sound waves are longitudinal, only transverse waves can be polarized, but all waves can form a stationary wave. The next question says, the diagram shows a stationary wave formed on a string of length 0.60 meters. 2 points on the string are separated by a horizontal distance of 0.30 meters. What is the possible phase difference between these 2 points? So pause the video now, unpause the video when you want to go through your answer. Now on the diagram, 1.5 wavelengths is 0.60 meters, so one wavelength is 0.40 meters. If 2 points are 0.30 meters apart, they're going to be 3/4 of a wavelength apart, so therefore you're going to be getting a phase difference of pi radians, so therefore our answer is D. The next question says, which characteristic of monochromatic light changes when the light passes from air into glass? So pause the video now, then unpause the video when you want to go through your answers. As a fact, during refraction, wavelength and speed will change, but frequency must stay fixed as it's a property of the source producing the wave. Our answer is C. The next question says, sound waves cross a boundary between 2 media x and y. The frequency of the waves in x is 400 Hz, the speed of the waves in x is 330 meters per second, and the speed of the waves in y is 1320 meters per second. What are the correct frequency and wavelength in y? So pause the video now, then unpause the video when you want to go through your answer. We know speed equals frequency times by wavelength. We know therefore speed is 1320 in y. Now we know that it must be 400 Hz because frequency is unchanged, so therefore it's 400 times by 3.3, our answer is C. The next question says, which of the following is correct when total internal reflection occurs? So pause the video now, then unpause the video when you want to go through your answer. Right, we know here that for total internal reflection to occur, it has to happen when the angle of incidence is above the critical angle and that ray of light is meeting a less optically dense medium. So our answer is B. The next question says, the diagram shows a ray of light passing through a rectangular glass block. Which row in the table correctly identifies the changes to the property of light as it enters the glass block? So pause the video now, then unpause the video when you want to go through your answer. Right, when a wave enters a denser medium, the wave speed decreases as the frequency stays the same, so therefore the wavelength must decrease. Our answer is B. The next question says, what is the speed of light in glass of refractive index 1.42? Pause the video now, then unpause the video when you want to go through your answer. Right, the speed in the medium we know from the equation sheet is the speed of light divided by the refractive index, pop in the values, and you get your answer of B out. The next question says, a layer of liquid of refractive index 1.6 covers the horizontal flat surface of a glass block of refractive index 1.5. A ray of light strikes the boundary between them at an angle such that it travels along the boundary afterwards. How does the ray strike the boundary? So pause the video now, then unpause the video when you want to go through your answer. Now, we know if the angle travels along the boundary, it's at the critical angle. We know sine critical angle is n2 over n1, which is 1.5 over 1.6, so the critical angle is 70 degrees. So if the angle is 70 degrees to the normal, it means it must be 20 degrees to the boundary, so therefore our answer is D. The next question says, a ray of light is instant on a glass air boundary of a rectangular block as shown. The refractive index of glass is 1.5. The refractive index of air is 1.0. The angle of incidence of the light at the first glass air boundary is 44 degrees. What is the path of the ray of light? So pause the video now, then unpause the video when you want to go through your answer. Right, we know sine critical angle is n2 over n1, so it's 1 over 1.5, so critical angle is 42 degrees. Now we can see here the light is hitting the surface with a lower refractive index and above the critical angle, so it'll totally internally reflect, so our answer will be D. Let's have a look at some questions to do with mechanics. So a moving object has a uniform non-zero acceleration. Which velocity time correctly shows this? So pause the video now, then unpause the video when you want to go through your answer. Right, so in this graph, on a velocity time graph, the gradient is acceleration. This means the gradient needs to be constant and not zero. Our answer is A. The next question says, a ball is thrown vertically upwards with a velocity of plus 3 meters per second. At the maximum height, the acceleration of the ball is. So pause the video now, then unpause the video when you want to go through your answer. Now, when considering the vertical, the only force acting on the object is gravity. Gravity has a strength of 9.81 meters per second and is acting in the opposite direction to movement, downwards, so it must be a minus. The answer is D. Next question says, a car accelerates uniformly from rest along a straight road. Which graph shows the variation of displacement of the car with the time? So pause the video now, then unpause the video when you want to go through your answer. Right, the greater the acceleration, the greater the displacement, which leads to a curvature in the graph. So therefore you can see it's increasing. Our answer is B. The next question says, an object is dropped from a cliff. How far does the object fall in the third second? Assume G equals 10. So pause the video now, then unpause the video when you want to go through your answers. Right. In that third second, we don't know S, but we know U is starting to be 20 meters per second because it's starting that third second. The V, the final speed at the end of the third second, is 30 meters per second, and the acceleration is told to be 10. We know time for the third second is 1, so we say S equals ut plus a half at squared. We get 25 meters out. The answer must be C. The next question says, a girl jogs at 2 meters per second in a straight line for 30 seconds, turns around and returns to a start point 20 seconds later. What is her average velocity and her average speed? So pause the video now, then unpause the video when you want to go through your answer. Now, as the girl is returning back to where she started, her displacement and therefore velocity is 0. Average speed is distance over time, so it's 2 times by 30 times by 2 to get her overall distance divided by 50, which is 2.4 meters per second. Now, the distance is 120 meters because she goes 60 meters and then back to the start, which is 120 meters. So we're working it through. Our answer is A. The next question says, a ball is kicked given an initial velocity v at an angle of 35 degrees to the vertical. The ball remains in the air for a time t. Which of the following gives the distance travelled over the ground? So pause the video now, then unpause the video when you want to go through your answer. Right, distance is velocity times by time. As we measure the horizontal distance, the velocity needs to be the horizontal component, which is v sine 35. So therefore distance equals v sine 35 times by t. The answer is C. The next question says, an aircraft moves from rest with a uniform acceleration along a horizontal runway. After travelling 1,600 meters, it reaches a speed of 80 meters per second. What is the acceleration of the aircraft? So pause the video now, then unpause the video when you want to go through your answer. Right, we know u is equal to 0 and v is equal to 80 from the information given. The displacement is 1,600 meters, so we use suvat, v squared minus u squared equals 2as. We get the answer of 2. Our answer is E. The next question says, the diagram represents a mass that is moving in a straight line at a constant speed up a slope of a constant gradient. Which statement about the forces acting on the mass must be correct? So pause the video now, then unpause your video when you want to go through your answer. Right, the object is moving with a constant speed in the same direction, so it's not accelerating, so it has no resultant force acting upon it. So our answer is F. The next question says, a lift and its passengers with a total mass of 500 kilograms accelerates upwards at 2 meters per second squared. What is the tension in the cable? So pause the video now, then unpause the video when you want to go through your answer. Right, the correct answer is D, because force equals mass times acceleration. So it's 500 times by 2 from the information given is 1000 newtons. The resultant force is the overall force, so it's the tension upwards minus the weight downwards. So tension is the resultant force plus the weight, so it's the 1000 plus that weight, 500 times by 9.81, it's 6000 newtons. The answer is D. The next question says, an apple is on rest on the ground. The diagram shows three forces of equal magnitude. W is the weight of the apple, P is the push of the apple on the ground, and R is the normal contact force of the ground on the apple. Which row shows Newton's first and third laws being applied correctly? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is D, because in Newton's first law there's no resultant force as it's at rest, so W equals R because it's on the same object. But in Newton's third law the force must be the same type and act on different objects, so it must be R and P. So therefore the answer is therefore D. The next question says, which of the following statements about the forces in Newton's third law pair is not correct? So pause the video now, then unpause your video when you want to go through your answer. Right, the answer is B, because the forces do not act in the same line, they don't act on the same body, they are equal in magnitude, they are the same type. The answer is B. The next question says, the mass of fuel in a racing car decreases during a race. As a result, the lap times decrease. Which of the following could explain this decrease? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer is going to be C, because friction is a constant force, so if there's less mass, there's less contact on the ground, there's less friction. The maximum speed occurs when the drag equals the thrust, so it's unaffected by the mass change. But we know acceleration is equal to resultant force over mass, so if mass decreases, acceleration increases. It must be C. The next question says, a deep space probe travelling forwards at a constant speed is briefly acted upon by a force at right angles to its motion. What is the effect of this force on the forward speed and the sideward speed of this probe? So pause the video now, then unpause the video when you want to go through your answer. Right, a resultant force will cause an acceleration in the direction the force acts, but inertia will be present in the direction at right angles to the force. So it means the forward speed is unchanged, but the sideways speed will increase. The answer is C. The next question says, if we look at this parachutist, okay, the vertical forces act on the parachute and the vertical forces act on the parachutist are shown. From looking at the equations, which of these equations, if any, is the direct application of Newton's third law to this situation? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is C, because the first equation is Newton's second law, and so is the second, because it's on one object. Number 3 is just not correct. Number 5 is also Newton's second law, as it's on one object, but the Newton's third law is on two objects, so it has to be equation 4. The answer is C. Now let's have a look at some questions on materials. So the first question says, on one end of a 50 centimeter length of wire is attached to a support. A load is attached to the free end of the wire, which extends by 2 millimeters. Which of the following is the strain for the length of wire? So pause the video now, then unpause the video when you want to go through your answer. Right, strain is equal to extension over original length. So it's 2 divided by 500, we'll convert the centimeters into millimeters, so we get 0.004. The answer is A. The next question says, a student used a balance to measure the mass of a cube of length x, and then this student also measured the mass of a large cube with size of length 1.5x. Which of the following is the density of the larger cube in terms of the density of the smaller cube? So pause the video now, then unpause the video when you want to go through your answer. Now we know density is mass over volume. Now the mass is the same for each one, so it's a standard value, but the volume is 1.5 times greater, so it's 1.5 times cubed, because the length is 1.5 times greater, so the volume is 1.5 times cubed, so therefore 1.5 cubed equals 0.30, so you get your answer of D out when it's 1 over that value. The next question says, a specimen of material fixed at one end and subjected to a tensile force of 60 newtons. The length of the specimen became 9 centimeters as shown. The force was increased to 100 newtons. The length of the specimen became 11 centimeters. The specimen obeyed Hooke's law throughout. Which of the following was the original length in centimeters of the specimen before any force was applied? So pause the video now, then unpause the video when you want to go through your answer. Now, as Hooke's law is obeyed, force and extension are directly proportional. An increase of 40 newtons causes an extension of 2 centimeters. So 1 newton will cause an extension of 0.05 centimeters. So therefore 60 newtons cause an extension of 3 centimeters. So therefore the original length had to have been 6 centimeters. It was A. The next question says, a spring is stretched by a force F. The energy stored in the spring is E. The spring is connected to a second identical spring. The combination is stretched by the same force F as shown. Which of the following is the total energy stored in the combination of the two springs? So pause the video now, then unpause the video when you want to go through your answer. Now we know elastic potential energy, the energy in a spring, is a half kx squared. So in series we know the total spring constant will half, so therefore it's k over 2. So for the same force the extension therefore is doubled. So you can see it's going to be equal to c. We now look at the next question. Says the Hooke's law equation is F equals k delta x. So which of the following gives the base units of k? So pause the video now, then unpause the video when you want to go through your answer. Now remember, whilst you can get values in newton meters to the minus 1 for k, that's not in base units. So we say k equals F over x, so it's n over m, but we have to put those into those base values. So newtons becomes F equals ma, so it's going to be the units of mass times units of acceleration, kilogram meter seconds to the minus 1, divided by meters, so it's kg s to the minus 2 there, so our answer is A. The next question says a spring has a spring constant of 6 newtons per centimeter. It is joined to another spring whose spring is 4 newtons per centimeter. A load of 80 newtons is suspended from this spring. What is the extension of the composite spring? So pause the video now, then unpause the video when you want to go through your answer. Now we know the total spring constant is 1 over k equals 1 over the individual plus 1 over the other individual. So 1 over 6 plus 1 over 4. So k therefore is 2.4 newtons per centimetre. X is F over k, 80 over 2.4. X is 33 centimetres. The answer is D. The following graph shows the extension of a sample of a type of rubber as different loads F are applied and then gradually removed. What is the best estimate of strain energy in the rubber when a load of 80 newtons is applied? So pause the video now and unpause the video when you want to go through your answer. Right, the elastic strain energy is the area under the graph. So the values for extension must be measured in meters when we work it through, not millimeters, so our answer is C. The next question says, a micrometer screw gauge is used to measure the diameter of a copper wire. The reading with the wire in position is shown in diagram 1. The wire is removed and the jaws of the micrometer are closed. The new reading is shown in diagram 2. What is the diameter of the wire? So pause the video now, then unpause the video when you want to go through your answer. Now to find this value, you've got to find the value for each screw gauge micrometer measurement and then find the difference between the two. So in diagram 1, there's 1, 2, 3, 4, 5 different links on the main spindle. Each is going to be worth 0.5 millimeters. So you can see it's going to be 2.61 millimeters on that side. Then on diagram B you can see the difference. It's going to be, if you look across onto there, it's going to be 0.15 millimeters. So find the difference between the two and we get our answer out to be B, 2.45 millimeters. The next question says, two wires X and Y are made from the same material. Wire Y has twice the diameter and experiences twice the tension of wire X. The wires obey Hooke's law and have the same original length. Wire X has extension E. What is the extension of wire Y? So pause the video now, then unpause the video when you want to go through your answer. Right, we know force is equal to kx, so therefore extension is force over spring constant, so it's 2f over 4x because we know the diameter is doubled, so therefore it's going to be 2 over 4, so it's a half, so the answer is B. The next question says, what is represented by the gradient of a graph of the force against the extension for a wire obeying Hooke's law? So pause the video now, then unpause the video when you want to go through your answer. Right, we know gradient is the change in y over the change in x, so it's force over extension. That is the spring constant. The answer is B. The next question says, forces are applied to the ends of a rod so that length increases. The variation with load L of extension E is on the rod is shown. The point P is the elastic limit. Which shaded area represents the work done during the plastic deformation of the rod? So pause the video now, then unpause the video when you want to go through your answer. Right, work done is always the area between the line and the extension axis. Now plastic deformation occurs after the line starts to curve, so the answer will therefore be C. The next question says, a wire W has mass m and radius r and is made from material of density ρ. The masses, the radii and the densities for 4 other wires are shown in the table, which has the same length as W. So pause the video now, then unpause the video when you want to go through your answer. So the answer to this question is going to be D, because we know that as the wires are made from the same material, the density for each wire is the same. We know density is mass over volume, so density is going to be mass divided by volume. So as the volume is 4 over 3 pi r cubed, we can therefore work out the answer would therefore be D. The next question says the graph shows a variation of extension with the forces for 4 wires, which two store the same elastic strain energy at their maximum extensions. So pause the video now, then unpause the video when you want to go through your answer. Right, the answer for this one is going to be B, because we know E equals a half kx squared or a half fx, so therefore from this graph we can see that it's the area under the curve, so therefore P and S are the same as when the force is halved, doubled, the extension is halved, so our answer is going to be B. The next question says here, a spring at obeys Hooke's law is stretched. What pair of graphs show the variation of energy stored E with the extension of delta L and the variation of E with force F? So pause the video now, then unpause the video when you want to go through your answer. Now you can see here that both relationships are not directly proportional, so therefore we know E is a half kx squared and E equals a half fx, so therefore the answer has to be D. The next question says, a graph of stress against strain up to the breaking point is drawn for 4 samples of wire, A, B, C and D. Which sample of wire has both a low elastic limit and a large region of plastic deformation? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer is going to be C, because C has a lower straight line section, so a lower elastic limit, and a larger curved region, plastic deformation. The answer is C. The next question says the stiffness constant and the Young modulus are terms used in physics. Which row shows the correct application of these terms? So pause the video now, then unpause the video when you want to go through your answer. Right, the stiffness constant is used for different objects, so the Young modulus is consistent across materials for different objects, so therefore our answer is D. The next question says clay can be worked by hand to create pots of various shapes and sizes. Which of the following words describes a property that makes clay suitable for this process? So our answer is going to be C, because clay needs to be adjusted into different shapes and sizes, which is what malleable will mean. The next question says, a sample of steel in the form of a wire is subjected to an increase in load. Which of the following is the best description of the elastic limit of steel? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer is going to be C, because the elastic limit is the highest stress where the object does not become permanently deformed, leading to our answer to be C. The next question says 2 metal specimens X and Y are stretched until they break. Y has a greater Young modulus, a greater ultimate tensile stress, and is less brittle than X. The stress strain curve for X is shown, which is the stress strain curve for Y. So pause the video now, then unpause the video when you want to go through your answer. Right, we know Y has a steeper gradient, so therefore has a higher Young modulus, because that is the gradient. Y has a greater peak, so has a greater UTS, because it's a greater value. And Y has a greater inelastic behaviour, as it's less brittle, so our answer is going to be B. The next question says, solid spheres A and B have the same mass but different densities. The diameter of sphere A is 2d and the diameter of sphere B is d. What is the density of sphere A compared to sphere B? So pause the video now, then unpause the video when you want to go through your answer. Right, volume is 4 over 3 pi r cubed. When the diameter is doubled, therefore the volume will increase by a factor of 8. We know density is equal to mass over volume, and the mass is the same, so it's going to be 1 over 8, or D. The next question says, what is the unit for stiffness? So pause the video now, then unpause the video when you want to go through your answer. Right, stiffness is force over extension, so it's going to be work done times by distance over extension, so it's joules times by meters over meters, so therefore it's going to be joules, meters the minus 2 there, so therefore our answer is going to be A. The next topics is going to be electricity. So the definitions for current and potential difference both include. So pause the video now, then unpause the video when you want to go through the answer. Right, current is the rate of flow of charge, potential difference is the work done out of the circuit per unit charge, charges in both definitions, the answer is A. The next question says, which of the following graph shows how current varies with potential difference for a negative temperature coefficient thermistor? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is going to be C, because for a negative temperature coefficient, the higher the temperature, the lower the resistance. So when the potential difference increases, the temperature increases and the resistance decreases. So a decrease in resistance is indicated by a steeper line on the IV graph. The answer is C. The next question says, an ohm meter was used to measure the resistance of length L of nichrome wire as shown. This is then repeated for different values of L. The diameter of the wire was measured and the cross-sectional area of the wire was calculated. A graph was plotted. The gradient of the graph was equal to the resistivity of the nichrome. Which row of the table shows the quantities which were plotted on the Y and X axis? So pause the video now, then unpause the video when you want to go through your answer. We know resistivity is Ra over L, so therefore if the gradient is delta Y over delta X, it's Ra over L, so therefore our answer is D. The next question says, a meter ruler was used to measure L. The following measurements were recorded, so which of the following is the most appropriate uncertainty to use for the length of a piece of wire? So pause the video now, then unpause the video when you want to go through your answer. Now, when you're taking repeated values, absolute uncertainty is range divided by 2. So it's going to be 0.5 over 2, which is plus or minus 0.25 or plus or minus 0.3, so our answer is going to be C. The next question says, the diagram shows a graph of current against potential difference for an electrical component. Which of the following components will produce a graph of this shape? So pause the video now, then unpause the video when you want to go through your answer. Now our answer is going to be C, because when the temperature of a negative temperature coefficient thermistor increases, the resistance will go down, so therefore our line will curve upwards. The next question says, which graph shows the variation with current of potential difference for a filament lamp? So pause the video now, then unpause the video when you want to go through your answer. Right, for a filament lamp, when the potential difference increases, the temperature increases and then the resistance increases. So on a VI graph, this is shown by the line curving upwards, so therefore our answer is going to be A. The next question says, a wire of cross-sectional area 5 times 10 to the minus 6 meters squared is made from a metal of resistivity 50 times 10 to the minus 8 ohm meters. The potential difference across the wire is 6 volts and the current is 3 amps. What is the length of the wire? So pause the video now, then unpause the video when you want to go through your answer. Right, we know resistance is V over I, so 6 over 3. Therefore length is Ra over resistivity. So you pop in all the values, work it through, and we get 20 meters. The answer is D. The next question says, a digital meter has an accuracy of 1%. The meter is then used to measure the current in an electrical circuit. The read on the meter varies between 3.04 and 3.08 amps. What is the value of current with its uncertainty? So pause the video now, then unpause the video when you want to go through your answer. Right, we can see that if there's a variation of plus or minus 1% in the values, then the largest value is 3.08 plus 1%, which is 3.11. The smallest value is 3.04 minus 1%, which is therefore going to be 3.01. So the range is 0.10 or plus or minus 0.05. Our answer is C. The next question says, which of the following is an SI unit for electromotive force? So pause the video now, then unpause the video when you want to go through your answer. We know EMF is the work done per unit charge into a circuit, it's a voltage. The SI derived unit is the volt. The answer is D. The next question says, the following circuit contains 2 resistors of equal resistance and a diode. Which is the reading on the digital voltmeter? So pause the video now, then unpause the video when you want to go through your answer. Right, we can see that the diode is acting against the current flow, so there'll be no current flowing down that path. Each resistor has the same resistance, each output will have the same resistance. So as the potential difference is proportional to resistance, it'll take an equal share of the EMF. If the EMF is 3, you divide it by 2, it's 1.5 volts. The answer is C. The next question says, a cell of EMF and internal resistance is connected across a fixed resistor of resistance R. There's a current in the circuit and a potential difference across the fixed resistor. The term lost volts refers to the difference between the EMF and the terminal PD. Which of the following is an expression for lost volts? So pause the video now, then unpause the video when you want to go through your answer. Right. The voltage is the current times by the resistance, so the lost volt is the current times by the internal resistance. We know current is the same in a series circuit, so the lost volt is I times by small r. The answer is B. The next question says, a circuit consists of three identical 1.5 volt bulbs connected to two 1.5 volt cells. The switch is now closed. Which row describes the change in brightness of bulb Y and of bulb Z? So pause the video now, then unpause the video when you want to go through your answers. Right, when the switch is closed, X and Y are now in parallel, so this means X and Y have a lower equivalent resistance than before. In a potential divider, the potential difference is proportional to resistance. When the resistance is lower, the PD is lower, so Y and X will be dimmer. So if X and Y take less PD, Z will take more PD, as total PD out equals total EMF in, so Z will be brighter. The answer is C. The next question says, a cell of EMF 1.5 volts is connected to a 5.0 ohm resistor. The terminal PD across the cell is 1 volt. What of the following is the current in the circuit? So pause the video now. Let's unpause the video when you want to go through your answer. Right, we know current is potential difference over resistance. It's 1 over 5.0. Remember, the potential difference is the EMF minus the terminal. It's going to be the terminal PD, sorry. So it's going to be the EMF minus the lost volt. So it's 1.0. So you get 0.2 amps. The answer is B. The next question says, identical resistors are connected in 4 combinations P, Q, R and S between terminals X and Y. What is the order of decreasing combined resistance between X and Y? So pause the video now, then unpause the video when you want to go through your answer. Right, we know equivalent resistance increases in series but decreases in parallel. R will contain only a parallel configuration, so we'll have the lowest resistance. P contains only a series configuration, so we'll have the highest resistance. S contains both, so we'll have more resistance than Q, which only has one resistor. The answer is A. The next question says, the circuit consists of two resistors, resistances of 10 kilo ohms and 50 kilo ohms, and a component Y. A 6 volt supply is provided. The electric potential of the bottom wire is 0 volts. The current in component Y is negligible. What is the electric potential at junction X? So pause the video now, then unpause the video when you want to go through your answer. Right, in a potential divider, the PD is directly proportional to the resistance. At X, it has 5/6 of the resistance of the circuit. That means that's 5/6 of the PD. 5/6 of 6 volts is 5 volts. The answer is D. The next question says, a cell of internal resistance and an electromotive force is connected in series with the resistance of resistor R. The resistance and EMF remain fixed. The internal resistance of the cell changes over time. Which graph best shows the variation of current in the circuit with internal resistance? So pause the video now, then unpause the video when you want to go through your answer. So the answer to the question is going to be B, because we know that if R and E remain fixed, the only factor which can affect the current is the internal resistance. So when the internal resistance is increased, the current flow will decrease, which gives a graph with a negative gradient. This will be sloping slightly due to the resistive effects of the circuit. Our answer is B. The next question says, 3 resistors are connected in parallel across a power supply as shown. The power dissipated in each of the resistors is 2 ohms, 3 ohms and 4 ohms. What is the ratio of P2, P3, P4? So pause the video now, then unpause the video when you want to go through your answer. Right, we know that P equals I squared R, so the power is directly proportional to the current squared. The current splits as an inverse of resistance, so P2 takes 2/9 of the resistance, so takes 7/9 of the current. P3 takes 3/9 of the resistance, so takes 6/9 of the current. And P4 takes 4/9 of the resistance, so takes 5/9 of the current. The answer is C. Then a battery with internal resistance is connected to a parallel arrangement of 2 resistors and a switch is shown. Initially, switch S is open. What happens to the voltmeter and ammeter readings when switch S is closed? So pause the video now, then unpause the video when you want to go through your answer. When switch S is closed, the resistors are now in parallel, which decreases the equivalent resistance. So it means R is lower, so PD is lower. This gives a lower value on the voltmeter. In a series circuit, as the overall resistance of the circuit decreases for the same EMF, the circuit must increase, giving a higher value on the ammeter. The answer is A. The next question says, a battery is connected to a network of six resistors as shown. The potential difference across 5 of the resistors are labelled on the diagram. What is the potential difference across resistor R? So pause the video now, then unpause the video when you want to go through your answer. Right, in loop 1, the PD is 1.2 volts plus 4.1 volts plus 3.7 volts, so 9 volts. In a circuit, according to Kirchhoff's laws, each loop must have the same PD, so loop 2 must have a PD of 9 volts. This means that the missing resistor has a value of 4.4 volts. The answer is A. A negative temperature coefficient thermistor is connected to a resistor in a cell as shown. The temperature of the thermistor increases. What is the changes to the ammeter and the voltmeter reading? So pause the video now, then unpause the video when you want to go through your answer. So, when the temperature increases, the resistance of the thermistor decreases. This means that the PD of the thermistor decreases, as in a potential divider circuit, the PD is directly proportional to the resistance. So this means the voltmeter reading goes down. In the circuit, as the total resistance is decreased, the same EMF is supplied, so the current increases, so the value on the ammeter will increase. The answer is C. The next question says 4 resistors, each of resistance X, are connected in network as shown. What is the total resistance of this network? So pause the video now, then unpause the video when you want to go through your answer. Right, we know that the resistance in parallel is 1 over RT is 1 over X plus 1 over X plus 1 over X, so it's 1 over 3X. In series, it's going to be 1 plus 1, so therefore it's 1/3 X plus X, so it's 4 over 3X. Our answer is D. The next question says, a battery of negligible internal resistance may be connected between 2 points P, Q, R and S of the network of resistors shown. Which connection will give the largest current and the smallest current in the battery? So pause the video now, then unpause the video when you want to go through your answer. Right, when you have them in series, PQ is going to be 3, PR is 3 plus 5, so it's 8, RS is 4, and QS is 5 plus 4, which is 9. So the highest current gives the lowest resistance and vice versa. So the highest current is PQ, the smallest current is QS. The answer is B. Let's now finish off with some questions on periodic motion. The mean radius of the Earth's orbit around the Sun is 1.5 times 10 to the 8 kilometers. What is the mean centripetal acceleration of the Earth about the Sun? So pause the video now, then unpause the video when you want to go through your answers. We know for this question the answer is B, because A equals omega squared R, or 2 pi F squared times by R. Now again, remember that F is going to be 1 over the time in seconds, so 3.15 times 10 to 7, and R is the value in meters, not kilometers, so you work it through to be 5.968 times 10 to the minus 3 radians per second squared, B. The next question says, the graph shows a variation of displacement x with time t for an object performing simple harmonic motion. The time period is t for the oscillation. Which graph shows a variation of acceleration with t for the same object? So pause the video now, then unpause the video when you want to go through your answer. Right, our answer is going to be C, because acceleration is directly proportional to displacement but in the negative direction. So an AT graph is a reflection of an XT graph in the x-axis. The answer is C. The next question says, the graph shows the variation of velocity with time for an object performing simple harmonic motion. The period of oscillation is t. The maximum acceleration of the object is equivalent to what? So pause the video now, then unpause the video when you want to go through your answer. Right, the gradient of velocity time graph is the acceleration. The maximum value of acceleration is when the graph is the steepest, which is when t equals 0. The answer is A. The next question says the total energy of an object that's performing simple harmonic motion is what? So pause the video now, then unpause the video when you want to go through your answer. Right, the total energy can never be 0 as it never has any potential energy. The total energy is not a maximum at the maximum speed as the gravitational potential energy is at a minimum, and the total energy is not a maximum displacement as the kinetic energy is a minimum. So our answer has to be D. The next question says the graph shows a variation of displacement x with time t for an object performing simple harmonic motion. Point P has a displacement of 2 centimeters from equilibrium. What is the velocity of the object at point P? So pause the video now, then unpause the video when you want to go through your answer. Right, we know from our equation sheet V equals plus or minus omega times by the square root of a squared minus x squared. So we can say omega is 2 pi f. Remember, f is 1 over t, so you can see it's going to be 1 over 0.8 from the graph. We know it's 3.9 centimeters is the amplitude from the graph. We know that the value of x is 2, because it's still in the question. Pop it all through, we get about 26 meters per second. Our answer is C. The next question says, for a particle moving in a circle with uniform speed, which of the statements is incorrect? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer is C, because the displacement always occurs perpendicular to the force is always perpendicular to the velocity, as is the centripetal force, and the kinetic energy is constant as the magnitude of velocity never changes, it's a uniform speed. So therefore our answer has to be C. The next question says, a revolving mountaintop table restaurant turns slowly, completing a full rotation in 50 minutes. A man is sitting in a restaurant 15 meters from the axis of rotation. What is the speed of the man relative to the stationary point outside the restaurant? So pause the video now, then unpause the video when you want to go through your answer. Right, we know omega is equal to 2 pi over t. So it's 2 pi over 50 times by 60, because we work in seconds, not minutes. So that gives us omega. We know V equals omega r, so we multiply that value by 15. It's 3.14 times 10 to the minus 2 meters per second. So our answer is going to be A. So that brings us to an end for this revision session. So if you've been successful and you've learned in this revision session, you should be able to answer A-level physics examination style questions, assess your understanding of A-level physics, and understand what topics you need to improve upon for AQA A-level physics. So thank you so much for participating in this revision session for AQA A-level physics on multiple choice questions for physics paper 1. Thank you so much and have a lovely day.